Good morning. Okay, today is the 29th of October. This is the nybbles.io daily programming stream. My name is Jeff. I write code every day. Sometimes I stream it here on Twitch. I'm going to try to get back into Basecode here. I've had a couple fits and starts. But mostly just bug fixing. So, man, I'm not sure what I want to do here. So, syntactically, there are a handful of things. Hey, Raul Rita, Gun Games. Yeah, doing okay. Yeah, I'm in the south, let's say, of the U.S., southeastern U.S., so I'm in the Eastern time zone. All right, what do I want to do? Yeah, so what's left syntactically, meaning new elements of the language, the base language. We've got the with expression, we've got for loops, and we've got type parameters on structs and unions and procedures. And then whatever pattern matching switch thing I'm going to do. And then I think there's a couple of enhancements that need to be made to parsing numeric literals for like scientific notation for floats and a couple other things like that. Those are minor. And then on the parsing side of things, I was last kind of experimenting how I wanted to do arrays. And I had kind of, for initializers, I'd kind of come up with this, and then maps would be very similar. Because essentially the base language is going to support two built-in collection types, arrays, dynamically sizable arrays and fixed arrays, and then an associative array, a dictionary. But yeah, I wanted to try to I keep looking at my list and I ain't thinking, okay, I just want to get the remaining parsing syntax done. Okay, so excuse me. So actually I've got tuples for parsing, maps. I have the array literal stuff. Data-oriented design, huh? So gun games, I kind of already have a series on YouTube for the data-oriented stuff. It's my C Kong thing, because that's all in C. There's no O there. I mean, here's the thing, right? If you're talking about Mike Acton's data-oriented design, it's a lot simpler than it sounds, right? See, I don't think people say this much anymore, but it used to be the case that, I don't know, I remember when I was learning back a long time ago, there used to be this input, process, output. Right? That was kind of a lot of articles, a lot of books. That was the model that they used, right, for everything. And we have a ton of layers now on top of stuff. But at the end of the day, what the data-oriented guys are trying to tell you is that that stuff that they were teaching you in books in the 70s, you know, input, process, output, that's it. That's all it is. It's still that. No matter how many layers of abstraction you put on top, how many fancy language features you add, at the end of the day, you have some block of code that's going to either generate data, you know, on the fly, de novo, right? Or it's going to take some input from somewhere, it's going to do something to it, and it's going to put it somewhere. Put the result somewhere. Input, process, output. And every problem that you try to solve in software, you can look at those problems in one of two ways, right? You can look at it as a modeling exercise, which is what OO tried to get everybody to do. Or you can look at it as there's going to be some input, there's going to be a process, there's going to be some output, and it's always that pattern. And what, you know, like Mike Acton in his talk was trying to get everybody to understand was you really can't approach problem solving that simplistically, right? You don't have to model anything extra. In fact, like his whole premise is that if you start modeling anything, and when I say model, what I mean is creating classes, creating types, creating new things. If you create new words, if you create new types, you are by definition expanding the problem space, right? And you're doing that without having solved the problem. Where the problem is literally, here's some data, here's some loops and if statements and stuff like that, right? And here's some output. And if you start putting other abstractions in the picture, well, you know, maybe those are gonna help, but most likely those are extra noise that are pushing you further away from the actual problem you're trying to solve. So at the end of the day, when I hear guys like Mike Acton, and I don't know who Stoyan Nikolov is, but I mean, I could listen to their talk. And again, you gotta be, boy, I kind of have run into this here a lot here in the past few weeks. In our industry, you know, it's not limited to software, right, or hardware. This happens everywhere on some level, but people pick up fads, popular things, right? So Mike Acton gave his talk back in whatever, 2014, 2015. It kind of sort of caught on a little bit, and it became a little bit of a buzz, and then you got guys like Casey and John who kind of trumpet that approach. Although I think, yeah, Casey's more, he really gets into code folding and stuff, but it's the same thing, right? But people are going to start making talks about this stuff, and I haven't seen this guy's talk, so I don't know what the content of it is. But Mike, I don't think, like, he wasn't trying to market anything. I think he was just speaking his mind generally. But you just got to beware, right? If people start making it sound more complicated than it really is, then they're probably trying to sell something, right? And it's not any more complicated than functions, data, that's it, right? Actually, I'll restate that. It's no more different than code and memory, right? That's fundamentally what data-oriented design is. There is nothing else there. There are no design patterns. There are no, I mean, your design patterns are, Knuth's books, basically. The art of programming. It's what are all the algorithms and common data structures that are out there. That's it. Those are your patterns. And yeah, I mean, so then here's the other side of this, right? So that's my opinion of, data-oriented design is no different, no more complex than just create a bunch of structs and variables and write some procedures that consume those, right? And do something meaningful with it. But here's where I think, how do I want to describe this? Okay, so everything happens, right, in the market for a reason. And the reason that, well, I think there were two reasons that OO kind of gained a foothold. But I think the predominant reason is that, and I'm trying to find a charitable way to say this, but I can't really. So I think a lot of managers in the 90s, probably in the early 90s it started, but by the mid 90s they were desperate. Let's face it, if you're just writing functions, you're just writing procedures and you just have data, then it takes discipline, right? It takes skill to not shoot yourself in the foot, right? It's data-oriented design is not for the faint of heart. And by that I mean it's not complicated. It's not like there's 200 things you need to learn about how to do the thing correctly. Doing the thing, writing a procedure, having input data, having output data, that's easy, right? Where you have to have skill and really, I would say it's 95% discipline, 5% skill, is how you organize things. How you name things, how you organize things, because there is now no methodology, there is no linguistic thing, OO, that is showing you or guiding you, and we can debate how well it does that. That's not really the point. The promise of it was, oh, look, this is going to help people design things and put things in cute little packages so that you don't have this big ball of mud, right? Because people were getting big balls of mud. And I remember quite a few of them. Because if, again, all you're doing, like if you take C as an example, if you're not disciplined, if you haven't built software systems of size before in that structured programming model, you're probably going to create a big old mess, right? And that's the part that, like, the guys who are pushing data-oriented design are not really speaking to, because they're just assuming that anybody who would dare to take it on, and again, I'm not trying to make it sound bad, it does not fit in the modern mentality of how these things work, right? If you're gonna write some C# code or some Java code, or you're gonna write some, Ruby and Python are kind of multi-paradigm, but again, the conventions strongly skew towards using classes, using, their moduling systems, and those give you a structure. They give you a way of the way in which things should look. And there are linguistic things, right, that help with that. Being able to import things from namespaces and other modules. But if you just, again, use C as an example of a procedural structured programming environment, it doesn't have any of those things. So it's up to you, the practitioner, to know how to reasonably structure modules. And when I say module here, there's no system there for that. It's just a procedure, right? It's just a discipline that you follow to make that happen. So that's the part I think that doesn't get a lot of airtime when folks talk about data-oriented design. And I just had a thought. So that, but then if you were to look at any of these companies' code, the reality is that those code bases are not going to be 100% structured, right? They're not going to be just pure C. It's like, I think in Mike Atkins' talk, he says they would prefer to do everything in assembly language, which is, an important point to consider. And then next, ideally, they would want to do everything in C, but C compilers don't get a lot of love these days, right? So they're not, again, we're talking about companies that are building things that have to work a wide variety of ISAs, and sometimes the compilers are just not there. But the C++ compilers are, because that's the hot shit. That's what everybody wants. So that means then that on some level, right, they end up having some C++isms sneak into their code, right? Whether they want that or not, and it probably varies from shop to shop, but you're gonna have structs with operator overloading, and you're gonna have some classes and some inheritance, it's gonna happen, right? Because then that's the other thing that happens is, okay, so like the DoD thing, if you come at that from a different angle, it's actually talking about, I think, so in the purest, most strictest interpretation, it's functions, data in, data out, that's it. But the reality is, like, there are things that C++ offers that are kind of nice, and so you don't have to just assume that all classes are evil, that all data hiding is evil, that all that stuff is just completely wrong. And you can take that approach, but C is C, right? It just doesn't have some things that C++ has that would make things a little bit easier to work with. And what I would say is, here's the difference, here's the distinction. I like to say the kind of programming I do is type-oriented programming, right? Not object-oriented programming, type-oriented programming. So what's the difference? The difference in my mind is again, it's not always this way, but in general, OO tries to approach things by modeling the real world, or at least what you might think the real world would be. So if I'm making a game, and in my game I have players, and players can have weapons, and weapons can have ammo and features, and a very primitive, naive OO approach would be to model those things explicitly. But if you've ever built a large game, you realize that's not going to work very well. You're better off having a generic entity system and yeah, those could be objects, and then dynamically associating entities to entities and making it data-driven. So that is more type orientation, right? That's looking at the problem and saying, okay, fundamentally this data structure is what I want. Now C++ lets me create a specialized type that will let me do that without having to write as much boilerplate code, right? And I maybe get operator overloading, and I get some other things that I can't do out of the box with C. I'm solving the same problem the same way. I'm using a data structure, I'm using a type, and I'm just using some of the features that C++ has to make that a bit cleaner, right? Versus modeling the things concretely, right? That's the trap. That's the pit of despair. Now, that's kind of on the design side. The reason that the data-oriented guys don't like, say, vtable-based inheritance and polymorphism is you're losing control. You're letting the compiler do something for you, but the trade-off is now your cache performance on your CPUs is impacted because the way in which the vtable inheritance gets implemented, there's levels of indirection there, and then it's probably going to kill something, right, performance-wise. And then again, if you're coming from an assembly language type perspective, you're going to want to put things into common shared blocks of memory. You're not going to want to have to walk the heap randomly for a lot of things. Those things just kind of turn off, programmers who don't typically work that way. And the more OO you get, depending on how far down the chain you go, the more control you lose, versus just data structures where you just, hey, this is a bag of bits, and okay, I allocate a huge block, and they're all the same size. And so if I do some simple pointer arithmetic or whatever, or index into it like an array, I get to the next block, and it just works. And I know, roughly speaking, that if I put that on an ARM chip, or I put that on a PowerPC chip, or I put that on an x86-64 chip, that I'm going to get pretty much kind of the same performance. So, yeah. Anyway, that was my long rambling on. But here's the thing about cache missing. Yes, cache missing is important. You should consider it. Here's my thing on that, though. You have to remember, especially if you're talking about game studios or game devs, they are not, I don't want to say this. They are exposed to hardware that 99.9% of programmers are not exposed to, even in the current era. Meaning that most people are not writing code for PlayStation 4 or Xbox One or what's the Switch, right? Most people, or even stated a different way, most people are not writing code that has to target all those machines and a PC. And there's trade-offs in both directions. In PC land, you have a lot of power, right? You know, even crappy PCs, I mean, I think John Carmack talks about this a lot recently, but even crappy PCs now that have like Intel, you know, video and whatnot, it's really not that bad, you know, compared to a console where things are really stripped down for cost control reasons. Yeah, they have an x86 64 ISA, but the bus is limited and there's, you know, timing issues and yeah. So long story short, this whole cache miss thing, again, I'm not saying it's not important, and you certainly probably, if you can build things that are cache friendly, you should. But on a PC, it isn't as big of an impact, right? On a console, big impact. On a PC, you know, it's not as big of an impact. Now, again, you can go from the angle of things could be a lot smaller, things could be a lot more compact, things could be not so bloated, and you know, all that's true. But on a console, you really don't have a choice, right? You, like as an example, there's a talk that I watched a while back, I'm trying to remember what it was. I'll put the link on the Discord, but it, you know, it was John Blow talking about their entity system in the Witness, and it was like they had 70,000 entities in the world, and on the PC, you know, it wasn't maybe the most optimal, but it ran fine. But on consoles, it was sucking wind because, you know, because of the unique architectural nature of the consoles, even though the hardware components were very similar to what you would have on a PC, the specific bus configuration and other limitations of that, they had to go back and optimize things, right? So, and on the PC, things get a little bit better, but you know, on the console, it's a make or break thing. So yeah, I mean, the whole cache miss thing is super important, and you don't want to be stupid and, you know, like blow 95% of the cache reads that you can get. But at the same time, it's levels of impact, right? And that's the thing, like, you look with these talks, what's the venue of the talk? If the venue of the talk is like CPPCon, well, you know, that probably covers a lot of stuff. If it's some game thing, then they're definitely talking about things that are just related to AAA gaming. But I would say Basecode it's going to be, you know, mostly, well, it's procedural, right? There's no objects, there's no classes. You could build it if you wanted it, but so I mean, I guess on that level, you know, it's going to be mostly data oriented, but I'm going to have facilities that kind of let you do the same type oriented development, right? You'll be able to do operator overloading and some other things that, you know, C doesn't let you do out of the box. Okay. Oh, now I gotta, what was I doing? Okay, yeah, so I remember now. So I'm being really lazy with the Bootstrap compiler. So for tuples, arrays, and maps, I'm using these kind of pseudo functions, right? To do this. It's not really an intrinsic. The parser's going to pick it up earlier, but from a parsing perspective, this actually ends up being a little easier right now. And I would just like to get the Bootstrap compiler to a point where it's functional, or fully functional. So when I redo it, I might revisit the syntax here. Although this doesn't really bother me all that much, to be honest. So, I don't know. I mean, it's either something explicit like this, or you use some symbol, right? And a lot of languages just use parentheses here, which, maybe I'll end up going back to that. Okay. So we have a prefix parser called tuple expression parser, and I've got that wired in. And I think, I already did the tokeny tokens. No, I did not. Did I already have the function? Maybe? Yeah, I already have the function. Okay. And it returns a tuple literal. Hey, Dr. Robot Vinnick. Where did I go? Well, I'm kind of in between Cincinnati and Kentucky at the moment. Louisville, Kentucky, actually. So Cincinnati and Louisville. Yeah, so I have my laptop, and I have one extra monitor. I don't have any more than that right now. And because I'm moving around a lot, I probably won't. Excuse me. So, yes, because I just have the two monitors, it doesn't really make a whole lot of sense I just do everything on the one monitor for now. And yeah, I'm sure you guys can read this a lot better. So, okay, so the Lexer will find the token. Yeah, Nibbles on tour. Yeah, right. And timing wise, for me, I'm starting 1 hour earlier than I was when I was at home, but it's like it's still the same now that I've adapted to the Eastern time zone. It's still roughly the same time for me. Like I'm getting up at the same time, but I know for you guys, it's over in Europe, it's a couple hours earlier. So I don't know, maybe that's good or bad, but. And I got a really big ass coffee cup because the coffee maker I have that I bring with me is one of these little coffee makers it's like a one, it's just like a one serving maker, and it's really slow. Yeah, I thought like Central European time it was like 9 a.m. or 10 a.m. or something, but so that's good. And of course, Gun Game stays up late, so now I'm more overlapping with his time. Okay, so actually, okay, so I just didn't do anything with it. Figures. My neocortex has got to like warm up now and remember what I was doing. Yeah, okay, so right hand side. And this is a Razer keyboard, but it's not the same one that I had at the house. I had to buy a new one. This is a, what is this? This is a Black Widow Elite, which, I actually like this one just from the simple perspective that the keys are all exposed. You know, the Black Widow, it's like a classic keyboard where you have to actually like pry up the keys because they're within the case. They're all mechanical, but it's just they're recessed, right? This, I think this is definitely designed for like serious gamers. Because like I say, none of the keys are recessed. They're all on the top and you can literally just like grab them and pull them off, which is kind of nice because then it's easy to clean. But functionally, it's pretty much the exact same keyboard. The switches aren't quite as clicky as I would like. I'm not sure which one these are, honestly. I think they're greens, but I'm not sure. And chat is in different colors. Oh, Romania. You show up as a very light green, and yeah, I'm gonna have to change my color thing. I can't read that. I'm doing okay. I'm traveling for work, so yep, on a slightly different schedule right now. So what was I doing? Make tuple type. Oh, now I can read you. That's much better. Do you have a link for that, Root Guy? Are there... You like it? Yeah, I'll have to take a look at those. All right, so let's go here. So how do I want to do this? Sweet. Dankeschön. Oh yeah, look at that. All right, I gotta save a link to that. Look at that later. That's like programmer porn right there. Let's see. How do I want to do this? All right. So. Not do that. Scope Mangler. How clicky are they versus, I think these are green switches. I wonder if it says on the bottom. I didn't even look. Shame on me. Doesn't say. This one's heavier though. I will say that. I'm not sure why. Let's see. Razor, Black Widow, Elite, switch type. Yeah, they're greens. That's what I thought, but yeah, they're really nice keyboards. I'm not a huge fan of how Razer runs their business, but their keyboards are good. Yeah, my DOS, I don't know, man. Like when I went around earlier in the month, I brought the DOS keyboard with me. It just, I don't know, it has issues. Maybe I got a dud, I don't know. And I just like the feel of the Razer. The ergonomics are just a bit nicer on the Razer, in my opinion. Okay, what? So it's a type, it's a composite type, so it has fields on it, which we need to, yeah, so actually, I'm being dumb. I don't want to do that. Oh. Right, we're not going to do that. Come on. Oh, it went to sleep. Come on, come back to me. Oh no, the ID crashed. Great. Sweet. Always love it when I do that. That's awesome. Yeah, I had, I brought a Razer to a client and recently here, and yeah, they told me not to do that. I'm like, come on, you know, 25, 30 years ago, this was the norm. Everybody got work done. Okay, so yeah, we just need the scope then. I did run into a guy recently who he actually uses the Dvorak layout. And it just like further cemented how old I was, because people were like, this doesn't work right. These keys aren't in the right spot. And I'm like, oh yeah, that's Dvorak. And they're like, it's what? I'm like, yeah, there was this different style of keyboard and it didn't really ever catch on, but that's what that is. And he was like the one guy, that's not right. I think I've met 4 people over the past 35 years that use Dvorak. Like they actually use it, which is kind of impressive, really. Okay. So this is going to be this. What are you complaining about? That's because I called the wrong function. Dope. Okay. All right. All right. So for tuples, there's 2 models here. One is value-based, one is actual, similar to the way like structs work. So if it's not an assignment, so let's see, add deposit type fields. So if it's an assignment or constant assignment, if it's a symbol, yeah, so I'm gonna have to do something. It's not a block, it's an argument list. Oh my goodness. I can't type. What the fuck? I can't type. Jesus Christ. Oh, Jesus Christ. Okay. Here's your little... Oh, come on. This is what happens when I go to meetings. My brain turns to mush the argument is going to be an element that's going to have a type. So all we care about is we need to build the fields. Yes. So is assignment So we just need to know if it's an assignment or not. If it's an assignment, then we know what the field name is. If it's not an assignment, then we have to generate a field name. So this would be like .1, .2, .3 or something for the or underscore. And then these, it would be first, second, third. So is the element an assignment? If it, we'll use that down here. Regardless, we're going to infer the type. And if that fails, that's bad. Because this is creating a type here. So this is kind of like the equivalent of defining a struct or whatever. So actually, this isn't an error. What has to happen here is we make it unknown, or unresolved, sorry. Or, no, I think I called it unknown type. My laptop is struggling. Hey, Slayer Darth. It's going well. I don't understand why they insist on moving things around. Seriously. Oh, yeah. So I put it on the tab now. Yeah, that's great. Okay. Yeah, mostly work. Although I think I've got a schedule window here that's pretty consistent for the time being, at least for the next month or so. So, hey, Voightcomp Phil. It's 5 o'clock right now in the morning, 5:14. So at least for the assignment case. No, not permanently. I mean, I am temporarily relocated, but it's just for work. This is just a corporate apartment. There's very little in here. All right, so we're going to loop over the argument nodes. If it's an assignment, we're going to add the assignment to the scope. Yeah. So if we can add the assignment to the scope, we make a field. We get the offset, put it in the tuple type. All right, let's test that case. Comment that out. Yeah, you know, the kids are fairly, I mean, this sounds horrible, but they're fairly self-sufficient. And most of that is just their age. You know, once they get into the teen years, they're don't need as much attention, just oversight. My daughter has more stuff going on though than my son. He just pretty much does schoolwork at home, and he makes flags. His new thing is he's selling flags on Etsy, so he's pretty into that. Since I'm doing the whole screen now, maybe it'll still be readable if I make things a bit smaller. Because I normally don't work. Is that still readable for you guys, or is that worse? Let me know. Because I don't usually work with fonts quite that big. The main reason I was doing it is because of the streaming. Yeah, I mean, if I put the stream full screen on my laptop, it doesn't look bad. Nothing's unreadable. Excuse me. This monitor I picked up, it's an Acer, and it's a 144 hertz refresh rate. Uh-oh, kaboom. Oh, darn it, Jeff. You so silly. Anyway, I was gonna say I really like the faster refresh rate. It's quite nice. Okay. Cool. We get a new scope. We get our tuple type, which has the scope. We add it, and we start going through the arguments. Yes, it's an assignment. And that blew up. Why did that blow up? Why'd that blow it up? Target element is null. Why is that the case? Because target symbol. Why is that blowing up? Ooh. What am I passing in? Hmm. Okay, so it's in there. Why? Oh, parser is. Hey, I heart coding. How's it going? Yeah, doing pretty good. Okay, so it's the comma. It's messing it up. Yeah, now that I think of it, I don't think I've ever debugged assignments in a comma separated list. So yeah, it's probably messed up. Yeah. Okay, so we are getting the variable, but it's not sizing it correctly because there it goes. Why? Ooh, wrong tuple. Oh, yeah. Okay. So it's getting, I'm calling initialize in the right place now, and it's getting a valid symbol name. So we should get a size on it. Then I gotta fix, on the parser, we gotta fix the comma, the pair thing. It's not handling the assignments correctly. I think I know why. That's correct, because it's a byte. All right. Very good. Okay, I'm going to take a really short break, and when I come back, we will try to fix that comma parsing stuffies. I will be back. Okay, I'm back. Looks like, no, did the break video work? Can't even tell. Looks like it may not have. Oh, sorry, I forgot to have set the loop on it. I fixed it. Yeah, this coffee maker is so freaking slow. All right, where was I? Okay. All right. Parser. I got to fix it. So the question is, okay, so we are hitting the comma. The left-hand side that comes in is, oh yeah, so it's not binding right. Yeah, that's not right. Alrighty. Let's see if that swap works. I don't know why it's. Need more power. The best thing, I was thinking about this the other day, would be to like offload all the streaming stuff onto another, because I have another laptop here. If I could offload all the streaming stuff onto that, and then this would just be my dev machine, but I'm not 100% certain how to best do that with OBS, so, or if it's even possible. I know, you know, with paid tools, you can get like mixing boards and all that good stuff. Hey, Lori Master. I don't know about the beauty thing, but glad to be back. Hey, Soding. How's it going? Joining me soon? Ah, very cool. Be careful, once you get spoiled, it does hurt to go back. Man, I'll tell you, I don't know why companies are so obsessed with these open office plans. They're horrible. They're, just can't stand them. So, what are we getting now? Good. Now we're getting the full assignment. And then left-hand side is... Ooh. Why is it a symbol? That's not... Oh, okay. So actually that does okay. So we're evaluator. Yeah, same idea. Can be named or unnamed. Right now I'm working on the named field scenario. But I had a bug in the parser for the comma. Better. Okay, better butter. Even better butter. All right, that fixes that problem. And okay, so this scenario works. So this is going to create a tuple. It's assigned to name tuple, and it's going to be first, second, third, which is going to be U8, U8, and string. Then I have to put the first one back in and add code to deal with the yeah, it's not bad. It's 16 plus 2. Very good. That is correct. All right, so, but this is gonna blow up. Well, it won't blow up, it just won't do anything. Okay, so if it's an assignment, we handle that. That creates a named field, very similar to the way a struct works. However, if it's not, then probably the easiest thing would be to just evaluate and then So what I did was the AST builder was composed inside of the parser, and at this moment I want to be able to use it again to just create an AST node on the fly, because I have code that is designed to consume that, and it's just easier to create that in a session. And really having, because every time we were creating a parser, what we call parse, the AST builder is stateless. It doesn't need to be reconstructed every time. So that was a little bit wasteful. The only thing I'd probably do to add, because there are a couple of collections on here, so I guess it's not, yeah, the scope stack. Okay, so here, I'll reset. Okay, so in here, I can say session AST builder. Assignment node. Do I like it? I don't know. So essentially, so we have two modes, right? For tuples. One where you just specify values, and those get implicit field names, _1, _2, _3. Or you can define actual named fields. Hey, Synox. And then it behaves more like a struct, essentially. And so you can do either of these. I'm doing pretty good. How are you? So if the argument is not an assignment, we evaluate it so we can infer the type, which now I'm thinking I need to do that. Yeah, let's do that. Yeah, it happens. So I have to create a token, a temp token that represents this field name I'm going to generate, create a symbol node, put the part in there for it, and then we create, so we have the assignment node pointer. So in this case, we're going to create a temporary one, and the left-hand side is going to be that new symbol we're generating, and the right-hand side is going to be the argument that came in, the value. So we're taking values and turning them into assignments. If we got an assignment, then we just use that assignment. And then we do the we add the assignment to the type scope for the tuple. So both of these should work now. I'm being very daring. I didn't put a breakpoint in. I suppose I should put a breakpoint. Hey, haunted broccoli. Broccoli could be haunted. So if this works, then hey, the Mad Dave. That's true. Yeah, if this works, then I need to add some validation code to this, because you can't, I don't think it makes, I don't think it makes sense to mix the assignment and non-assignment, although, yeah. Oh, the make? I think it's a little parallel, but not much. And this laptop has, I guess a third of the cores that I typically have on my machine at home, so. All right, so this is not an assignment node. So we're gonna make a field name identifier token that's _0. Make the symbol, and make the assignment. Looks pretty good. Yeah, they're both right. Okay, so now the question is, do I want this to be _0, _1, _2, or do I want it to be _1, _2, I'll leave it 0 based, whatever. Let's see if that works. Well, not exactly. Oh, but I'm not, I'm not initializing anything yet. Yeah, that's, yeah. Okay. I actually have to emit the code that sets the values. Oh, Jeff, you're just getting all ahead of yourself here. See, okay. So the type part works, right? It's making the type, the correct type. You can access it. So I can do third dot length. So this should be named tuple third length. This should be 6. Well, except, again, it's not being initialized. I gotta do that. So it'll be 0, but yeah. But the types are there, and so it's creating the types correctly. So the expression is working. I don't have the generic initialization code quite yet. So see, it recognizes the field names. So that's good. That part is Vark. So I don't know, some notes to myself here. What's missing here is let's take a look at what we got. So in the arrays one, oh, I guess I never committed this reformat here. So I did that probably a couple days ago. So in our tuple test case, right, so we have two tests, right? We're going to create an anonymously named tuple that has the values, the bytes 1, 2, 3. And then we're going to create a tuple that has named fields, first, second, third, 2 bytes in a string. And then just to kind of prove that the compiler is actually generating types correctly, and we can resolve the fields on those, we can do that. And I could assign to those, so that's all good. What this is not doing yet is it's not generating the initializers for the data. Gotta do that. So then in tuple type needed a name, custom name. So need to pass in a symbol element that gets generated. And in the, come on. There we go. In the CPP file, change the constructor to take that in and pass it through. The initialize needs to call the base class when it's done doing its custom stuff, because that's what calculates the size and other good stuff. On session, I pulled the AST builder out of the parser and put it in session. Because really, like, all of the session's kind of like our toolkit for, you create a compiler session and everything you need is on there. And the AST builder really doesn't need to be recreated each time. I mean, technically, even the parser really doesn't need to be recreated each time. It could be reused. And maybe that'll be the next refactoring so that we're not creating and destroying parsers we don't need to. But now we can access the AST builder from wherever. I'm not 100% sold in my own head that that's, like, I want to do that, but it was expedient in this case. So added an accessor for it, and then in the parse, we just need to reset the AST builder because it does track some state, so I guess it's not technically stateless. Yeah, and that's, yeah, anyway, that state probably should be somewhere else. And so I'll try to refactor that in a couple steps to make it not so stupid. And then in program, I had to add tuple type here to the variable section stuff. So we put out the reserve assembler directive to get space on the parser. So I had to swap the precedence order of comma and assignment. So comma is the lowest, and then assignment, and so on. So that this way, when you use the comma operator, the infix parser collects the assignments in between. It wasn't doing that before. We were getting incorrect associativity, which is not good. So then I added the tuple expression prefix parser and added that down here, the tuple literal, to that. So that's what triggers that whole cycle. Oh, and then I got rid of, I just pass a reference to AST builder in now, and we just cache that reference. So the tuple expression prefix parser is pretty simple. We create the expression node, we set the start location, we look for a left parenthesis, we get the comma separated list inside of it, we look for the right parenthesis, we get the end location. So pretty typical boilerplate stuff for parsing. Change the constructor for the parser because now we have to pass that AST builder reference through and cache it. Got rid of the destructor because it's not doing anything interesting, and I don't think it ever will. The lexer was not triggering the tuple evaluator for that tuple literal, so I added that in. I already had the function, just hadn't wired it into the map yet. And then an element builder, we need to generate a unique type name for the tuple. Create a symbol for that, pass that through. The initialize needs to happen inside of the evaluator because we need to do that after we've defined the whole type. This just kind of creates the header of it if you want to look at it that way. Then in AST evaluator, tuple expression. So we create the scope block for the type, we create the type itself, we add the type to the scope, then we loop over the arguments that we got, and if an argument's not an assignment, we create an assignment AST node, because add assignments to scope works off of an AST node. And so to reuse that code, I temporarily create that node. We assign that to our assignment node pointer in the loop. That's what gets passed in. We add the assignments to the scope. The scope here is the type scope. So we're creating a type, a tuple type, we're defining fields within it. If that's successful, we make the field, we add the field to the type. We keep track of whatever the previous field was because we're calculating offsets. We need that information for member access, and then at the end we call initialize on the tuple type. This is going to then set the name on the type. It's going to then call initialize, uninitialize in the base class, which is composite type. And that's going to go through the fields and it's going to compute the size based on the offsets. And then we return the tuple type out. And then in AST, made the constructor default, got rid of the destructor because we're never using it. I added a reset. Reset just sets ID to 0 and clears out the stack. Yeah, so then a reset just clears things out. And then on some of these nodes, I had shuffled like what the left and right side of the node meant. And yeah, so that's good. That's better. Better butter. All right, so sure I didn't break anything. So it's calculating the right sizes. Again, it's not doing the initialization code for it, so. And I don't know why, but somehow the sea lion EAP is setting the locale so that Git thinks it's Italian, and it is doing everything in Italian. It's kind of fun. And it's definitely sea lion. They did something in their terminal plugin. They broke it. Because outside of it doesn't do that. At least the last time I checked it didn't. I guess I should double check. Yeah, It's just funny, you know, it's like the things they break. Okay. Oh no, I can read it. I just thought it was really funny. All right, so I don't have a whole lot of time, so I guess let me make some notes here. What I want to do next. I did upgrade to Mojave, which by and large is fine. You know, I don't have too many issues with it, but I don't know, there's just been like these subtle little breakages everywhere. All right. So. Yeah. Actually, I'm in the process of getting my Italian citizenship recognized. My great-grandfather never naturalized, so I will be Italian again. Or I still plan on it, yeah. I would like to. A lot of logistics, you know, to work out moving from one country to another, but yeah, it would, definitely. Okay, so parser stuff. What I got left is the map one. I've got the array literal syntax. Again, it's generating the type information correctly. It's not doing the initialization stuff. I think the next step would be to get the map literal parsing stuff going. And that's going to be, actually now that we did the tuple thing, the associative array is going to be really easy because it's just going to look like this. So, yeah, that's what I think, roughly speaking, it will look like. And so again, getting this to parse would be the next step. And then with those done, so we'd have array literal syntax, we'd have yeah, so we'd have array literal syntax, we'd have tuples, and we'd have the map. And those are the core, besides string and any, those are like the core types that the compiler is going to provide. It'll be a hash table. It'll generate code that'll behave like a hash table of some kind. I don't know exactly how I'm going to implement it yet, but it'll be something along those lines. And again, this is for the Bootstrap compiler. This is just something good enough so I can start rewriting it, and then what we end up doing, it should be pretty straightforward. Yeah, the way hashing, yes. All the built-in types are hashable, and the way that I think I'll do hashing, it'll be very similar, I guess, to the way Rust maybe does it. So if we did something like person struct, and this had name string, I would just put, an attribute on here, and then this would point at some function, right? So then there'd be some func that takes in a person and returns back E64, right? So something like that. So this allows you to, if you create a custom type, this allows you to create your hashing algorithm and tag it to the type. And then we could do this, right? Instead of this being a string, this could be a person. And now, what I haven't thought of yet is like, if I'm going to support like struct literals, but I don't know, let's just assume that you can, right? Do something like this. So I guess I have to figure that out too. So, yeah, something along those lines. I don't think there's anything wrong with it. I just haven't really thought of, I guess you could make the argument that you could create a function, right, for it. I mean, you could just have a make person, I guess, but yeah, there really isn't an issue with it. I just need to add it to the parser so that I can turn it into something. Because again, really the syntax is going to be exactly this, right? Because you're just, if it has a default value, then it doesn't need to be assigned. Otherwise, you just assign whatever values you want. So yeah, I should make an issue for that. that to my parser tasks. But yeah, I think that's next. And then maps, the struct literals, and then type parameters on structs, unions, procedures. Yeah, and I think, well, then with and for, need to do those, let's add these back in. Let's put this over here. All right. Okay, yeah, so I think this week I've got, okay, for procedures with return types, I gotta assert that there's a return statement or that an output variable has been set. Type parameters for the stuff that needs some arrays, map, tuple, struct literals. And then we got the for loops with and defer. And I think, with the exception of a switch, and I was kind of thinking about switch, I think what I'll end up doing is having two things. I think I might implement something that's mostly like C or C++ without the goofy break stuff. You know, it'll work more the way you would assume that it should work. And then I'll come up with some other construct that's like a pattern matching. I don't know. I've been thinking about things related to that. I still haven't really come down too firmly on one side or another of how that should look. We'll do the first here. Then we'll come back to the struct literals. Yeah, so I guess my goal for the week is to try to get all these parsing translation tasks done. And then if the code generation is, you know, we can then loop back around and deal with code generation stuff, because we're gonna have to do, I have separate tasks for initializers, finalizers, and other stuff around for literals and things. So, yeah, but this is like, does the parser recognize it? Does it error check it mostly? Does it then get translated into the compiler DOM? And are things roughly slotting into the right place? Then we can go back and get the more complex stuff going. So yeah, that's the goal for this week. We'll see how far I get with it. I don't know. I'm optimistic I might be able to get a fair amount of this done this week. So that'll be good. All right, it's good to be back. Anybody have any questions, parting requests? I do still have to decide what kind of constraint syntax I'm going to use for type parameters. I haven't really come to a solid conclusion on that. Shoot, I love random questions. Is it pseudo-random or is it cryptographically random? Do you think there's a way to programmatically determine the original colors used in black and white film? First off, I believe there are software systems for those already, and I don't know a great deal about them. I'm sure the good ones are massively expensive. Here's what I would say, right? And like, I am not really, I haven't spent a lot of time thinking about this, but just off the top of my head, if I were to build a system like that or want to solve that problem, what I would probably look at doing is building a way for you'd have an AI or you'd have some kind of machine learning thing that can categorize things, right? So like you would say, okay, here's this actor, right? Or here's this thing, you know, let's say it's a she, and she is wearing a top and the top is yellow, okay? And then, you know, her skirt is orange. And again, you would be training the system to recognize these shapes, and then, you know, you're giving it the color information, and then it would go through and colorize things for you. I don't know how else you could do it. I mean, and I would have to think that the systems that are out there probably work mostly along those lines. And so then, you know, the machine learning / AI solution would probably be like, I don't know, 60 to 70% accurate or something. And then you probably would have to go back through and clean it up, right? Yeah. So yeah, I would Google. There's, like I say, I know there are existing systems out there, but there's a reason, like a lot of the old black and white stuff, like, at least to my knowledge, nobody's gone out there en masse and, you know, converted all of it to color, because I think it's, to Lori Master's point, you're probably not going to have perfect accuracy. There's going to have to be cleanup, always clean up afterward, and there's probably a fair amount of setup required to even get to the point where you can, you know, get some kind of automated coloring. So all right, everybody, I got to run. So I'll be back online tomorrow at 4 a.m. my time, Eastern time. So I'll see everybody tomorrow morning. Thanks for dropping by. Thought I'd made pretty good progress today. I think we'll make some good progress tomorrow. And yeah, I think, like I say, my goal is definitely to more or less be able to say that the parser and the translator are more or less done this week. I'm not saying that we won't make some little tweaks and adjustments, but yeah, I would like to check that part off. Then just we're working on finalizing some bytecode emit stuff, and then I would like to get the x86 and WebAssembly backends plumbed in, and there's still some other stuff we have to do in the compiler around scopes and some other things, but then I think that stuff we can get wrapped up fairly quickly and then actually try to start using it, which then my expectation there is I'm going to start building stuff in it, and there's going to be this cycle where I'm going to need to build a bunch of plumbing. But I think a lot of the plumbing I'll build in Basecode itself, and then we'll see if I have to add hooks in the compiler for some things. And obviously I still have to make the API surface area in the compiler for getting to the compiler DOM and manipulating it. So that's part of that bootstrapping cycle, so that we can actually do the meta programming. So anyway, all right, I'll be back tomorrow. Have a good one. Bye.